Welcome to our webinar, and my name is Johan Guma, and it seems that we are now connected, all of us, and I will start with a short overview and then hand over to Jose Almeida, our Director of Technical Sales. My name is Johan Guma, and I'm responsible for the Asia Pacific region for Russia and as well for key customers in Germany. And I'm very happy that we now present shortly the company SYSGO. So we are founded in 91 in Germany, so headquartered near Frankfurt and Mainz. We are around about 110 people, and since 2012 we are an independent part of the Thales Group. Thales acquired us, acquired SYSGO because of the hypervisor technology, and within Thales, we are the so-called center of competence for real-time OS and responsible for all the real-time OS inside the Thales Group. Regarding our expertise, we are providing a certified software platform for safety and security critical applications, and as well, we are trying to be very innovative. So we provide the first ZIL4 certified hypervisor on a Multicore, for example, and as well we have a lot of experience on the first software-based implementation of FTX as an example. Regarding our core business, so we have our product, Jose will introduce it later. It's a certified hard real-time operating system. And as well, we provide an embedded ELinOS, which is able to run inside Pike OS. And important for you as well, we're providing customer engineering service for BSP and driver development and other development parts which are related to the OS. And so far, we as well support a full product lifecycle and maintenance support. Very important point, which Jose will explain later, is our certification support and as well what we're doing regarding system architecture consulting. That was all from my side. I will now hand over to Jose, and then Jose will introduce himself.
Hello everyone, my name is Jose Almeida. I'm the Technical Sales Director for SYSGO. And just to give you some ideas about my background, I've been working on certification projects for the past 20 years with different operating systems, with different companies, with different standards, starting of course with avionics, but also railway as well as industrial. The presentation that I've prepared today is the following in terms of agenda. I will start by giving you an overview about what is certification. Then, before talking more in detail about how you can work with PikeOS, I will do a short introduction of PikeOS. The next item is Multicore Certification. This is basically an item which is not directly linked with PikeOS, but is something which cannot be forgotten when looking at the modern CPU architecture. Once we have gone through that, then I will give you an overview of the PikeOS certification kit and the final item, which will be how you can do your certification project with SYSGO and with SYSGO products. And we'll finish with the summary. So let's start with the definition of the certification. What is a certification? Certification is basically taking a product, a system, and proving that the characteristics of this system are compliant with some safety requirements which are needed for the product. This is mainly done through reviews, audit, and it doesn't cover only the product, but also all the things around that, including the company ability to build certified products. Certification is complex, so I'm giving in this slide some ideas about the certification project with PikeOS. What you see is that the effort that you will have in terms of certification compared to the source code size is something which is pretty small. Okay. If we look at the number of requirements and the number of source lines of code in this example project, we have a total of 55,000 lines of code. However, if you look at the test setup, we basically have seven times more test code than actual code which is running on the system. And from the documentation point of view, you see the impressive size of the documentation related to test case, related to execution of test applications. So typically 55,000 lines of code end up with over 1.6 million of test results that needs to be run. Okay, so this is not a very, from a developer point of view, well, the work which is done in terms of certification is much more than just writing some code. But certification is needed because this is the only way to ensure the safety of a system. So what you see in this slide is typically starting from the 70s, the number of passengers which are using aircrafts, and then the number of accidents. And the evolution there is basically linked to the improvements and the methodology which is used in certification. The bad news is that there are many standards. Okay, of course, when looking at avionics, we have DO178. Then we look at railway. That's a different standard. Automotive is still another one. Medical, industry, and not to forget, of course, military type applications. The good news, however, is that the methodology which is used in these different certification standards is very, very similar. We have always a number of different rules which always apply, which is, okay, we need to design, we need to have a controlled development process, we need to have test cases, we need to have a traceability, and we also need to make sure that the software which is running in the system is only the software that is needed. So we don't need, we cannot have software which is uncontrolled, which we don't know what it'll be doing, and we don't know what will be the side effects if something bad is happening in this software. Okay, so what do we need to certify? Well, as I already mentioned, we need to certify the organization. We need to look at the QA activities which are performed in the organization. We need to look at the software life cycle which is established. How do we document all this process? How do we do the development? Okay. We need a configuration management, and this typically means, well, you need to be able to have controlled way of building your system, which will not be just a developer which will develop some code, build it, and then release it. We need a proper defect management and correction system in place. This means, for example, from the SYSGO side, that each time there is a defect which is filed by either a customer or a developer, there will be a traceability between the code which has been modified in order to fix this defect and the defect itself. So we have a full traceability. Then this is only the organization. Then comes the product or the project needs. Well, we of course need to be compliant with all the process, but we also need to ensure that the safety requirements are handled properly, and we need a full traceability of all the safety related requirements to the software which is implemented, and we need to make sure that the software is only implementing the safety related requirements. And of course we have customer demands. This is typically, okay, we know that Airbus, for example, is certifying according to DO178. However, they may have some specific requirements. So for example, they want to have a DAL-C, which is a mid-range certification project, but they would like to do some additional activities just because they would like to do a little bit more. So depending on the project needs, we may have to adjust the standard development process and the standard documentation which is provided in order to fulfill the customer or the needs of a specific project. This could be also very well that, okay, we have some safety-related requirements, but what we see nowadays is safety is not enough. We need something else. We need security. And security will typically add some additional requirements, some additional documentation, some additional needs in the project. So what are the safety-relevant standards that we're considering at SYSGO? Our focus was primarily avionics. So we started by looking at DO178, B, and nowadays C. And what we figure out is that the certification process for this standard is almost the most demanding in terms of testing. Once we have established this process for DO178, what we did is that we extended this process in order to support not only avionics standard, but also some additional standards like railway, like generic industrial standards, as well as automotive. The nice advantage of this approach is that we are able to use from one single product, we're able to certify to different standards and to take advantage of having an operating system which is deployed not only in aircraft, but also in trains and automotive. And by this, you enable and you increase the level of confidence that you can actually have on a given product. So from the safety point of view, we've certified PikeOS according to DO178, B, C, can be certified up to DAL-A, but we have also done a certification for railway up to SIL 4, which is the highest standard in terms of certification in railway. Okay, and by the way, we did that with Multicore. So I will address a little bit Multicore concerns a little bit later, but we have done already a Multicore certification for railway applications. And same principle, we have extended this certification for industrial as well as automotive, ISO 26262. Aside of that, we also have activities which are doing common criteria certification. This is the security standard, and at the moment we are doing certification up to EL5+, which is not the highest standard. The highest standard in terms of security is common criteria EL7, but EL5 is already very, very high for this standard. In order to do that, well, we have started certification activities over 20 years ago, and what is very, very important for us is that all the certification expertise is done inside SYSGO. So all the certification engineers working on PikeOS certification are actually SYSGO engineers. These have one very interesting effect, which is, well, when a developer at SYSGO is developing code, is modifying the kernel, is modifying the driver, or is developing a driver, you already have in mind certification, which means that we don't have inexperienced people writing in the core and developing the core technology, where at the end of the day, you end up with something that needs to be completely redesigned, rewritten in order to be able to certify it. Okay. And of course, having certification expertise in-house also enable us to better work with our customers in order to define what will be the best certification approach together with the customer on a given project. Okay. Last point, but not least, we're doing that with one single product. So one product is able to fulfill all these different certification standards, as well as common criteria, automotive, avionics, railway, etc., with one single product. And then you benefit from the evolution on these different standards. Okay, so this was a basic definition of certification. Now let's have a look at what is PikeOS. Okay, so if we start PikeOS to start with, is another real-time operating system. This is needed because when you are talking about certification, it means that you need to understand what your system is doing. Understanding what your system is doing has to do with real-time features. You need to be able to know what are the response time. You need to be sure about the execution timing, etc., etc. Okay. It has been designed in order to safe and secure virtualization. So PikeOS is a safe and secure virtualization platform, meaning that it doesn't only run safe operating system, it can only safe application, it can do much more than that. It can, for example, run a Linux inside one partition, a control Linux, which can open, by the way, certain perspectives that I will describe a little bit later. It has been designed for certification, but not basic certification. It has been designed in order to do mixed criticality. Mixed criticality is a very important item because this is what basically enables you to save certification costs. It means mixed criticality. It means that you will be able to certify independently multiple applications running on the same system at different level of certification. The nice thing about that is that once you have developed an application, if your system is DAL A, which is the highest level, maybe you will have some maintenance code, which is not DAL A, but which may be DAL D or something like that. Well, you will be able to run these two application on top of PikeOS, and you don't need to certify your DALD application you don't need to certify your DALD application to the highest level, which would be DAL A. This is an interesting feature because it saves you cost in terms of certification. Now, what about Multicore? I will have a special section on that a little bit later. Multicore, PikeOS have been designed in order to support Multicore, and mainly in SMP mode, symmetric multiprocessor mode. Multiple guest operating system, well, PikeOS is a virtualization platform, which means that you will be able to run multiple operating systems on top of PikeOS. I already mentioned Linux, but you can also mix things like RX653 personalities with POSIX and some others that I will describe later. It also has been designed to be portable. Why is that important? Well, maybe you will have some application which will need a DAL A certification. DAL A certification means that it could make sense to use PowerPC, because PowerPC is the CPU which is widely spread in terms of certification for a DAL A. However, if you in an organization have another project which is not DAL A but DAL C, for example, maybe you will be able to benefit from other CPU architecture like Intel. Well, Intel could be certified to DAL C. We have done that in the past already. Well, but however, from the development point of view, it would be nice to have one single toolchain, one single process for development in order to address different projects. So being able to go for PowerPC with DAL A, but maybe Intel or ARM for a DAL C, with the same tool chains, with the same habits, with one single training from the developer's perspective, and one single methodology, because the certification kit from PikeOS for DAL C or DAL A is similar with the same kind of document and the same structure. Certification, well, of course, this is the subject of this presentation. PikeOS is certifiable, and certifiable with Multicore. Last item, which is important also for us, is we have no export restriction. This means that you don't have anything like ITAR restriction. This is true for the PikeOS binary, but this is also true for the PikeOS source code. The PikeOS source code is just one item that can be provided to customers, to certification authorities, and also for that we have no export restrictions. When talking about PikeOS, we're talking about an operating system, but we have a pretty large ecosystem. Okay, so we start with the PikeOS core technologies, and we have PSP, which is a basic adaptation layer to run on a specific hardware. Then we have device driver, add-on modules like hardware virtualization, personalities. I will get back on personalities a little bit later, but personalities is basically the API which will be used by developers when writing applications. Drivers, again, different models of drivers, add-on modules like file system, like network stack, like communication protocol, etc. Development tools, either command line, IDEs like Eclipse. And what you see here is certification kit as an add-on. So when you start a project with PikeOS, you don't immediately have to get the certification kit. You can start your development. You will have a certification kit, which is just an add-on component to the PikeOS kernel. It will be the same operating system if you're running a certified project or not. You don't have a different API. You don't have different toolchain. You don't have a different everything. It's the same thing. The only thing is, of course, when you're doing certification, you need to take into consideration the certification constraints when you're developing your application. This means that you need to have certification in mind right from the beginning. And you need also to set up the proper software architecture for your system in order to make it certifiable at the end. So it would be usually a good idea to start, maybe not with a certification kit, but at least to have some workshop with people at SYSGO in order to enable to minimize the costs associated with certification by setting up the right architecture right from the beginning. Supported architecture. I will be fast on that one. This is just to show you the different architectures that are supported with PikeOS. And again, it's the same product. It's not one product like PikeOS for PowerPC and one product like PikeOS for ARM. Even when dealing with hardware virtualization, it's the same exact product which is used. We just have one additional module which enables you to use additional feature like hardware virtualization. So PikeOS is a separation kernel. What does this mean? That we ensure the capability to run mixed criticality application. Okay, so you see in this example, low-level critical application, medium and high critical application. You can have, of course, as many of this one as you want. You can have multiple applications with the same level of criticality. However, the PikeOS separation kernel ensures the independence of these different applications. The independence is ensured by three basic elements. The first one is the resource partitioning. So we ensure that one low criticality application will not be able to interfere by accessing some common memory of a highly critical application. The second element will be time partitioning. And the last one is I/O separation. So this means that from the PikeOS perspective, you can actually decide on one given system, if you have different hardware components, which resources can be used by each application. And this means that you have a static configuration where you define, okay, the low critical application may want to use the graphical count in order to do some graphic display. MMU is used in order to map resources into only this partition to make sure that memory is allocated specifically to this partition, and eventually IOMMU is ensured to guarantee that DMA operations which are performed will only address valid memory area which are owned by a given partition. Static configuration. So PikeOS configuration is static. Why? In order to avoid runtime allocation, runtime modification of the configuration, which may end up with an unusable system. So space partitioning, that's basically a resource partitioning, that's basically MMU. One other key element when doing separation is time partitioning. So with PikeOS, you can decide, you can allocate time slots for each of your partition, and PikeOS will ensure that the transition is performed between this application in order to guarantee that when you switch from a low-level priority, low criticality application to a highly critical application, any activity which have been performed by the low criticality application will be cleaned up. So this means, for example, that you will clean up the cache, that you will ensure that the execution path when reaching the highly critical application will be under control. Okay. So we have some additional features in PikeOS, like we can have background partition. We can do much more than what is than just simple time partitioning, where you execute partition in sequence one after the other. I will not go too much in detail into that. If you have some idea, some question about that, I can answer that maybe later if you want to contact me. Let's have a look at more detailed PikeOS architecture. So PikeOS, we start from the hardware. You need some hardware. You need a bootloader, which may be certified or to some criticality level or not. This actually depends on your own constraint and what you want to implement in the bootloader. If you want to have built-in tests which are executed immediately in the bootloader, this probably means that you need some level of certification in your bootloader. This is not integrated in PikeOS. This is an external module that SYSGO can also develop, but which will be very tied to the system, to the CPU, to the architecture of your system. So this is, I would say, not something very generic. The next part that you see when using PikeOS is the PikeOS kernel. So PikeOS kernel is split into three parts, one which is generic, one which is related to the architecture, so this is basically this core CPU that you're using, and one which is related to your platform. So this code here is a code which is used in order to do the bring up of your system, in order to start PikeOS on your system. On the next layer, we have a specific component which is called the PikeOS system software. When we designed PikeOS, we actually wanted to make sure that the code which is executed in supervisor mode is reduced to the strict minimum, just to avoid some code with high-level privileges that will run in supervisor mode, and if something goes wrong, then it can eventually crash the system. So in PikeOS, only the kernel is executed in supervisor mode. Just to give you some ideas, we're talking about something which is between 5,000 to 7,000 lines of code, depending on the architecture, actually. And then, well, in a traditional operating system, you have some additional services that you need. You need to do the initialization of the system. You need to load the application. You need an application loader. You may need some drivers which are not critical. So what we have decided is to split these kind of activities and put them in one module, which is called the system software. The important part being that the system software is executed in user mode. So it will already have less privileges compared to the PikeOS microkernel. And a failure in the system software will typically have less impact than a failure in the microkernel because it's not executed in supervisor mode. And then the top level, that's the applications. And what you see here is that we have different type of application, different type of personalities, starting with PikeOS native, POSIX, RTOS, as well as fully virtualized guest operating system. Why do we want that, and why would you like to have that in your system? We have a DAL-A project. Okay, the core function may be DAL-A, and in that case, maybe using RTOS could be an interesting option. But now maybe you have some kind of maintenance application. Let's imagine that you have a maintenance application and you want to be able to connect a computer on the network and have some interaction with this maintenance application. One easy way would be to have a web server on your system. If you want to do that on RTOS, that's something which could be quite expensive to develop and which is not available. However, we have Linux On Linux, you have web servers which are available. You have database. You have a lot of scripting technology. You have a lot of things which are available almost for free, almost. This means that it could be interesting to say, okay, I want to have my DAL-A application, which is RX653, but because I have a DAL-D or a DAL-E application, I will use a Linux personality in order to host this application. And because I'm able to use Linux for a very low level certification, then this means that I will be able to benefit from the Linux ecosystem, because an application running on Linux on top of PikeOS is just a Linux. You can reuse any existing code in Linux and just get it to run directly on top of PikeOS. And you can get it to run next to a very critical application. Okay, with PikeOS ensuring the independence, PikeOS ensuring the safety of your critical application, and ensuring also the security, meaning the separation between your critical application and your non-critical application. Your non-critical application may be being connected to Ethernet, even to Internet. Okay, this is an extreme example using DAL-A next to DAL-D or DAL-E with Linux, but of course we have other personalities which will match the needs for, I would say, mid-range certification, mid-level certification. By the way, I'm mentioning Linux running next to a very critical application. This is typically the technology which is used in railway application, whereas they want to have very critical applications which are controlled. However, they want to have communication which are established with so-called black channel technology, whereas they want to have a network stack, but they don't need to certify the network stack. What they are doing with PikeOS is they are running SIL4 application on PikeOS native or in Ada actually, and then next to it running in Linux in order to run a network stack, and this network stack being certified to SIL0, which is the lowest certification level. So what I mentioned in this slide is PikeOS ensures the isolation between the different partitions. Different partition being different software modules. Of course, if you are putting multiple applications in one system, maybe you have some needs for communication, maybe you have some needs for device driver. Well, PikeOS initially is defining communication through application queuing ports, sampling ports, which are a communication channel defined in the RX653 standards. And we have also extended that with file-based communication, meaning file-based drivers with open read-write classical IOCTL, as well as all the technology which are typically used like events, IPC, mutex, semaphore. So you have a huge range of methods, of tools in order to communicate or to use device drivers to communicate between the different applications or to use different device drivers. The important thing is that you control everything. By default, an application, a partition, doesn't have any communication right, and it will be up to you to then define what will be the communication privileges, what will be the communication rights of a given application. I've already mentioned personalities. This is a non-exhaustive list of personalities which are available on PikeOS. One other interesting aspect of personalities on top of PikeOS is that it enables a customer on a specific domain to use a personality and API that is well known to him. If you're in the automotive area, you probably don't want to use an API which is RX653, because RX653 has been designed typically for avionics. Okay, but if you are in avionics, RX653 makes sense for you. So you will be able to select the personalities which are the most adapted to your application, to your domain, and also by doing that, you'll be able to reuse legacy application. Because if you already have an application which have been designed, implemented in RX653, you will be able to use that on PikeOS. You will be able, maybe if you have another application which is POSIX, maybe you will be able to reuse it directly with PikeOS. And you can mix all of that together, meaning that you will be able to put on the same system one RX653 application which was already developed next to another application which was developed with POSIX, for example, in a different partition. You don't need to migrate your application so that they all use the same type of API. Just a few words about Multicore certification. Well, let's start with the typical architecture of a multi-core CPU. Well, what you see here, and one of the main problems related to multi-core certification are the interference between the different cores or CPU which are running or used on the system. You actually have so-called shared resources. Of course, in a single-core system, you have shared resources which are between all the IOs and the memory. But in multi-core, you also have shared resources which are much more complicated to handle. That's the caches, for example. And you have one module here which ensures the coherency between the different cache area, which will generate some additional constraints. Knowing that, multicore have been designed in order to optimize the average execution timing. This means that they have not been designed in order to have a way to control worst-case execution timing. This is too bad because when talking about certification, well, the most important thing is the worst-case execution timing, not the average execution timing, because you need to guarantee that your application will be able to execute always respecting your timing constraints. Okay. The architecture that I shown before was a very simple architecture. The reality is much more complex than that. In modern architecture like Freescale P2041, you have not only the cache coherency issues, but you also have a crossbar, which is the current switch fabric core net, which is ensuring the communication between the different elements, between all the IOs, between all the cores, and you have quite a lot of cores. Okay, so you see the complexity of this architecture. This makes the certification complicated. Not only the complexity of the architecture, but, well, what is the SOC design? The architecture of modern SOC, which is using multicore, which have a lot of internal integrated peripherals, is very complicated. Okay, and you have a limited information, you have access to limited information in terms of design. What about the safety features? What about the robustness of such complicated, complex systems? What about the in-service history? In order to use the device on a Dell A project, you need to prove a certain number of hours of execution, of usage of this multi-core CPU on maybe a Dell B or a Dell C project. We don't have yet this level of in-service history on most of the modern multi-core systems. Of course, interference channels, shared caches, coherency protocols, not only that, but shared bus, shared devices, and also the fact that a multi-core system is not just two cores put one next to the other, or four. It's also a lot of additional things which are in the system. And this brings to a level of complexity which is complicated to handle. Well, in general, multi-core certification is something which is which needs to be considered very specifically to one project. The OS on its own cannot solve the multi-core certification problems. We have a certain number of things to consider, like worst-case execution timing. Well, the worst-case execution timing will be controlled partially by the operating system, partially by the application, and partially by the knowledge that you have of the system. If you have some execution of mixed criticality application in a system, on a multi-core system, you may need to consider what applications are executing at one point in time and what are the possible perturbations by this application. One easy way to explain that is to say, okay, you have maybe, let's consider this example and let's consider this timing. So in this example, we have 4 different applications which are executing. Some are very critical, like the partition 2. Some others are at the same level of criticality. One easy way to handle that is to say, okay, when I'm running at one point in time a given partition, okay, I want to be able to understand the worst case execution timing. If all my applications which are running at one point in time are at the same level of certification, I have a consistent system in terms of artifacts. So I know at every point in time what is doing application A, what is doing application B. So I will be able to have a certain level of confidence about the execution timing because I know exactly what this application will be doing. However, if I have one application which is at a very, very high level of criticality, and then executing, let's say, del A, and then I want to execute at the same time an application which is del E. It means that you are trying to execute an application which has a high level of certification where you know what it's doing, and at the same time on the same core you are generating perturbation done by application where you have basically no design. So of course this is an extreme example. You have no design, you have no clue what the application is doing. In other words, you don't know what are the possible perturbations from this non-certified application to your certified application. So one way to control that is say, okay, if I have one single application which is at a very high level of criticality, maybe I will do what I'm doing here, which is I will stop all the core on the system for a given amount of time and just run this very critical application in one core. Of course, I'm losing a little bit the benefits of multi-core, but I'm losing that only on a very specific timing. And from the rest of the time, I will still be able to benefit from the multi-core architecture. In general, when talking about multi-core certification, we need to look carefully at a number of items. The first one is SOC complexity. We have a very complicated SOC. What are the way provided, the means also provided by the SOC in order to control the interference, to control the different application which is running. IOMMU technology may be something which is interesting in this case in order to ensure independence of IOs between the different partitions. Okay. What about the hardware interference channels? What are the real timing requirements from your system? When talking about multi-core, we are always thinking about what are the cache coherency issues. Okay, cache coherency issues is something which will have influence in, I would say, the range of the microseconds, 100 microsecond range. If you have timing requirements in your application which are in milliseconds or maybe tens of milliseconds, then you have ways to justify the fact that you can not ignore, but you have the interference on the cache coherency under control. And then this is no more a problem. Okay. And of course, you need some safety arguments. So you need some built-in tests provided by the operating system, some by the application. In other words, unlike standard certification, a multi-core certification is something which is deeply linked with the application. We don't have at the moment, and we think it will be difficult to have a generic approach for multi-core certification. We need to consider each time the application needs. We need to consider what the SOC is providing in terms of mechanism, in terms of robustness in order to perform the multi-core certification. PikeOS certification kit. This is one of the elements that you will get in order to ensure to be able to do the certification of your system. Some history. I've mentioned already that SYSGO have been doing certification for more than 20 years. Well, we started our first certification project back in 1996. And we have experience on different level of certification, from DEL A to DEL D, or to DEL E actually. Not only with one single company, I mentioned Airbus, this is a well-known reference, but we have other references working with FIA, with EASA. Important point is that SYSGO is working directly with certification authorities, meaning that we have we had several times the avionics authority in-house in order to audit our process, to audit our processes, to audit our test infrastructure, to audit all the elements which are relevant to certification. We did that, of course, for avionics, but also for the other domains. What about the elements in PikeOS which are relevant for certification? Well, if I take the PikeOS architecture, of course, the PikeOS microkernel, the PikeOS ISP, the PikeOS system software, and the PikeOS PSP are relevant for certification. The personalities are also relevant for certification. We have actually a modular approach, which means that we'll have a certification package which will cover the PikeOS microkernel, another one which will cover the architecture, and then additional components for certification which will cover the POSIX personality, which will cover the RN personality, etc., depending on which domain you're actually addressing. Okay, so we have packages which are covering the different components. The PikeOS PSP is something which is typically linked to a specific project, because this will be related to your hardware. Maybe you have some hardware which is actually developed specially for your project, and then you need some minimum adaptation. Not only because the hardware is adapted to your project, but because you will have some built-in tests which are defined for specifically for your project in order to cope with your certification requirements, your safety requirements. So this will be something which cannot be provided as a generic package, but which is something that needs to be adapted to your project. What are the safety standards that we're looking at? I've already mentioned all of that, the railways, the automotive, the avionics, and the general industry standard. What needs to be considered when doing certification? You need, of course, to consider the entire development process, from the QA process, the planning process, the development process, starting from the requirements, the design, the coding, the integration, and then the testing, all these typical cycles. Okay, so I've took some elements which are part of the certification kit for avionics. Well, the planning process. What you see in these slides are all the standard plans which are needed, plans and standards which are needed for the certification in avionics. What is important from our standpoint is that because PikeOS is certified, have been certified on different versions, PikeOS have been certified for many years now, all these standards and plans have already been reviewed many times by certification authorities, which means that we're not starting something where eventually we'll have some surprises in the planning process, which will force us to redevelop, to modify a number of things. Okay. And then what is interesting is the other part of the certification kit, which means what do we provide to a customer who wants to do a certification project with PikeOS. Basically, we provide every element which is needed in order to prove that we're following the proper development process, starting from the high-level requirements, the low-level requirements, high-level design, low-level design, as well as verification and validation test result, validation and verification test case, and of course the traceability down to the source code. The level of documentation which is provided depends on the level of certification that you need to reach. If you want to reach DEL A DEL A certification, of course you will need the PikeOS source code. but the PikeOS source code for a Delta project is not needed. So we will adapt the content of the certification kit depending on the level of certification that you want to reach. BSP validation test suite and SYSGO test framework is optional. I will go back a little bit later on these items when I talk about how we do the certification with SYSGO. Of course, there are additional considerations that needs to be addressed. Things like what is the worst case execution timing. This is an additional document which is an analyzed document in conjunction with the specific test suite, which is doing timing analysis, partition analysis, worst case stack usage, tool qualification data or records, and of course support to the certification authorities. We are developing PikeOS. If you want to do a certification project where you use PikeOS, most likely you will need support for us to explain how PikeOS is working, answer the question from the certification authorities. This is all the things which are part of the PikeOS certification kit. How do we do certification? Well, the nice thing when using PikeOS in the certification project is that it's up to you to define your own certification strategy. You can basically decide that you want to do the certification on your own. So basically what you will need is only the PikeOS certification kit. And the PikeOS certification kit contains all the elements which are needed in order for you to do the certification. So this means that, for example, device driver, PSPs or BSPs in general are elements that you can develop, and will provide you, in this case, a PSP validation suite, which will ensure that the PikeOS certification artifacts that SYSGO is providing is not modified because you have developed your own PSP. So you will get a test suite that you need to rerun in order to validate your own PSP. It's not a validation in the certification from the certification standpoint. It's only a validation that the PikeOS kernel is still working properly and is still compliant with the certification artifacts which have been developed. Of course, that's the first option. This option makes sense if, for example, if you are developing your own hardware, or if you have a specific device driver that you're implementing because you have developed your own FPGA. In that case, you know very well the hardware, and it makes sense for you to do the PSP. Of course, there is another option. Maybe you want to use COTS certified hardware. In that case, you probably don't have any added value in order to developing the BSP artifacts. In that case, it could make sense that SYSGO develop that and provide you a package, which is a full certification package for the system, starting with the built-in self-test, the PSP, the different drivers, and in that case, of course, SYSGO takes the responsibility of the certification of this specific part. We have, of course, mixed schemes. We have schemes where we have a customer who say, okay, I want to have PikeOS certified on this hardware. I would like SYSGO to develop and certify the PSP. However, I have one very specific driver, and this very specific driver is something that I want to develop. And I want to certify it because this is my own design, because this is an FPGA, and there is no generic parts there. This is something that can be managed also. As I said, it's up to our customer to define what they think is the best way to certify the system. What about certification expertise? What we most of the time do is we know very well PikeOS, so it makes sense that we also help you at the beginning of the project in order to define the best architecture from your application, which will optimize the utilization of PikeOS, benefit from all the PikeOS features in order to minimize the certification costs. Not to forget long-term support. If you are doing a certification project, you probably want to keep that running for a number of years. Okay, what is the life cycle of your system? Do you plan to have some recertification? Do you plan to have certification technology insertion, like retrofit? This is something that can be planned, but the nice thing is that we have long-term support contracts, which enable you to plan in advance, well, which again can be adapted to your needs in order to plan what will be the best way for you to handle your certification and to handle the certification not only during the first phase, but for the 20 years where your system will be deployed. And of course, this is based on certifications process, like we have established a security and safety board, which enable us to analyze all the different problems which are reported in PikeOS and provide to our customers, which are certification project with a valid certification support, provide them some analysis of all the PRs in terms of what is the safety impact, not only on the PikeOS kernel, but also on the personalities and the add-on components like communication stack, like file systems, etc., etc. And this typically is an established process which is linked to the customer project, where we provide for the very specific items used in a customer project on a regular basis. We provide so-called safety built-ins, which gives them some indication or some analysis. Most of the time, the safety built-ins are empty, but if there is a PR which may affect a safety feature of PikeOS, which is in the version being used by the project, then the customer will be able to take this data and make his own analysis, own safety analysis in order to figure out whether or not this have an impact on his application. And just to finish, we're getting close to the end. PikeOS have been designed for certification. For certification on different standards, but starting with in mind the AS certification standard in avionics, in railway, and all the different domains. It has been designed for multiple, for mixed criticality application, being able to host different criticality application. SYSGO has over 20 years of experience in certification, with the certification expertise being done in-house by SYSGO engineers, which makes a lot of difference when it comes to discussion with certification authorities, because we have both the knowledge of our product as well as certification process. And one thing to keep in mind from our point of view, every project is different. Every project has different needs. And because we have this in-house expertise, because we have the expertise in certification, we are able to adapt the certification needs, the way you will do your certification, and will be able to fulfill the requirements in terms of what will be the best suited certification approach for your project.
Okay, and maybe I can add as a statement from our customer. So if we support a certification for our customer, then always they were able to get the certificate for their project. We are a little bit out of time. I know that there were some technical issues at the beginning, and we checked as well if there are any questions. And yes, we do have one question from Alexei Demyanov. Maybe, Jose, you may answer that?
Yes. Okay, no, so the question is what is the difference between a PSP and a BSP? Mm-hmm. A PSP is basically the code which is used in PikeOS in order to boot up the system. So let me go back to the PikeOS architecture slide. Okay, here. Okay, so a PSP is this part here, the platform support package. This is a code which is in charge of the initialization of the system, which is just doing the start of PikeOS. A BSP is basically this, a PSP, plus a set of drivers. Okay, because in PikeOS, the driver can be hosted at different levels. They can be hosted inside a partition, which is the best approach when talking about independence, when talking about certification, about security. But they can also be hosted at different elements. But because they can be hosted at the application level, it means that inside the PSP, by default, you don't have any driver. Okay, so a PSP is a PSP plus a set of drivers.
I hope that answers your question, Mr. Demjanov. And so, do we have other questions? I cannot see that. Even in the chat window, there is nothing at the moment. So, maybe I just wait a few seconds. Okay. Yeah, if we then have no other question at the moment, then I have to say many thanks to you for joining our webinar. Many thanks to Jose to present our safe and secure real-time OS. And we will provide as well the documents and maybe as well the recording of this webinar for you. And then I have to say many thanks for joining us and have a good day.
Thank you for joining. Have a good day.